So a couple things, right? If you see that you're multiplying, these bases don't have to be the same, but if the index is the same of the root or the radical that you're multiplying, then you can actually combine those into one individual multiplication problem. But with that skill, though, you can actually start with combined multiplication and then separate the two. So this is good because what you can do is, if you're going to simplify these, if you ever see they're not perfect squares or perfect sets, I guess we'll call them, then you can use kind of prime factorization to yank stuff out. Okay. Now, for the most part, we are dealing with squares, some cubes, and then they're going to throw some of the other indexes at us, usually like 4s and 5s. I don't remember seeing anything beyond that, but I could be wrong. Yeah, if you use prime factorization, every pair would be a perfect square, or every triple would be a perfect cube, if that makes sense. If it doesn't, that's okay. We're going to see some examples. But from those, that's what we're kind of splitting up here. Okay, so we're going to simplify this one. And again, the calculator will do this work for you, at least some of it. Not all of it, but some. And so what am I going to do? I'm going to take this 4 times the square root of 24x to the power 5. And I'm going to find factors of 24 that I want the biggest perfect square, right? So you could say, again, don't use 1 as one of the factors, but 2 and 12, okay, that would work. Maybe you would want to use 8 and 3. Okay, that doesn't seem like it works. How about 4 and 6? That looks good. Are there any others? Nope. No, these are the only factor pairs. Of course, 1 and 24 works, but we don't want the 1. Now, you'll notice right now I'm not even focused on the x to the power 5. I don't care about that. I would like if you didn't care about it yet. We're going to get there, just not yet, right? So I'm going to take that 4 and 6, and instead of writing 24, I'm going to write 24 as the square root of 4 times the square root of 6. Okay, and the reason I'm doing that is because the square root of 4 is a perfect square for 2. So then I have 2 times the square root of 6. What about this 4 in here in the front? This is not number 4 like the fourth problem. That's one of the factors in this problem. So we got to multiply that down here as well. Okay, well, what about that x to the power 5? Yeah, let's do that now. And yes, we'll deal with 4 times 2 here in a second as well. But instead of writing this as the square root of x to the power of 5, I'm going to write it. No, that's what I'm going to do. But instead of just x to the power of 5, I'm going to write this as x times x times x times x times x. And the reason I'm doing that is because now I'm kind of looking for, you could say, the prime factors. I'm looking for factor pairs. Pairs that match because they would be perfect squares, such as these two x's. Again, that's a perfect square for x. So the square root of x times x, I'll show that work. The square root of x times x is x. Okay, but I have another set. I got these two x's, right? So that would be the square root of those two x's, x times x, which you could write, for this one, let's take that back. Let's write that as x squared, just so you can see a different format for that. The square root of an x squared, remember, we saw this last time, but the square root and a exponent of 2 kind of undo each other, and then you're left with just that x. Now that last x we have is the square root of x because there's no other x's to pair this last x with, so we got to keep that by itself. And I know that x times x is x squared, and then we still got that multiplied by the square root of that purple x. So this is in 2 parts right now. Let's combine them, because that's really what we want here. So anything on the outside of the square root needs to stay on the outside. And we'll do, right here, we'll do 4 times 2, which is 8. Okay, now I'm going to take this x squared and then multiply it by the 8 there. And then the square root, we have the square root of 6 and the square root of x, which I'm going to combine into one square root. And that's it. Now, here's the thing. The x to the power 5, I kind of use, again, just for myself, I would look at that as x to the power of 5 over 2. And I know I can yank out two x's by themselves, which just leaves me with another x to the power of 1/2, which would be x squared times the square root of x. Now that's just this portion right here, and if that makes sense to you, use it. If not, you're probably gonna have to use this stuff until it does. On the other hand, though, on the calculator, if you had typed in 4 times the square root of 24, it would have simplified that for you as 8 times the square root of 6. So you could have gotten this part at least from the calculator, and then you might have had to do some work to get the x's on that.